Okay, welcome to Nested Loops. We're going to do the observer pattern today. So I'll turn it over to Don.
All right. So chapter 18 is the observer pattern. And the author is continuing the discussion on the e-commerce case study. And one thing he introduces here is this categories of patterns that originally came from the Gang of Four book. So kind of everything we talked about so far in the book, all the patterns, they actually kind of follow some common organizational scheme. So okay, first let's introduce the categories of patterns. There are three patterns that the Gang of Four introduced. One is creational, one's structural, and one's behavioral. And in this chart, the authors put all of the examples we've covered in the book, all the patterns we've covered, into each of these categories. So abstract factory, singleton, double-checked locking, and factory method all are creational, which means that they involve creating or instantiating objects. Then facade, adapter, bridge, and decorator are all structural because they bring existing objects together. And then strategy pattern is the only one that's categorized so far as behavioral, which means to give a way to manifest flexible or varied behavior. So the author notes that when he first started studying patterns, he was surprised that bridge and decorator were structural instead of behavioral. But he said that kind of was his misunderstanding of how the Gang of Four sees these things and classifies them. For them, the structural patterns are used for tying together existing functionality. And in the bridge pattern, we typically start with abstractions and implementations, then bind them together with a bridge. In a decorator pattern, we have original functional classes, and we want to decorate that original functional class with additional functions. So it's tying together functions, therefore it's structural. So that's their definition, is to bring together existing objects. So anyway, he kind of says that in practice of using these methods, then the objects that are brought together are separate to begin with. And in his use, he found, especially with the cat-cam problem, is he needed to separate things out more. So it was kind of a good reminder when using the bridge pattern that he really should have had it more separate. So in addition to these three categories that the Gang of Four created, the author also suggests a fourth category decoupling. He's found it valuable to think of a fourth category, and the primary purpose is to decouple objects from each other. And he says it's almost like it's a subcategory of behavioral. And the only reason he's making a fourth category is because the intent is to reflect on how he looks at patterns and focus on their motivations. So instead of just sticking to the strict patterns or the strict categories that the Gang of Four introduced, he wanted to focus more on motivations instead of just these, I guess, hard rules for categorizing. But yeah, the first pattern that we'll talk about for decoupling is the observer, which is the best example of decoupling pattern that the author can think of. And as you'll see, it's really about interaction between one class and multiple other classes. So it does a good job of decoupling. So before we introduce the pattern, we'll look at the additional requirements that have been added for the e-commerce case study. So this new requirement is to take an action when there's a new customer. So we've seen this a lot in web application development. Whenever we're creating, especially like a new user, we want to react, like do multiple things because of that creation. So in this case, we want to send a welcome email to the customer, and we want to verify the customer's address with post office. So when you first see this problem, the basic approach that you might try is to just have your method in customer class call two other classes that do these two things: send a welcome letter and verify address. And it's pretty easy to do it that way. And if you're certain that you know all the requirements, then it's pretty easy just to hard code this together. Then you can see that you have 3 distinct classes with distinct responsibilities. The customer, when it's added, when a new customer is created, it'll make calls to the other objects to have the corresponding actions take place. And then the welcome letter will do its job of creating the welcome letter for the customer to let them know they were added and verifying their address with the address verification class. But the problem with this is that requirements always change. So hard coding approach works fine the first time, but they always change. For example, we might have to support a different company's welcome letters, which would require a different customer object for each company if we were going to do it this way, because it would need to call a different class. So we're going to look for a way to do it better, which in this case is the observer pattern. The intent of the observer pattern, according to the Gang of Four, is to define a one-to-many dependency between objects, so that when one object changes its state, all the dependents are notified, and then they can update automatically or do some action automatically. And what it really comes down to is it's like a notification engine, just within your code between classes. So the pattern comes up because often you have a set of objects that need to be notified when an event occurs, and you want it to all happen automatically, but you don't want to change the broadcasting object every time, which is the situation we would be in if we did it the other way, is that we would have to modify this add customer method to call different classes. With the observer pattern, we don't want to change the broadcasting object. So instead, we have objects that are listening for broadcasts. So this pattern also goes by the names of dependents or publish subscribe, which might make some people think of message queues, which are also pub sub. And there's also a similar process in COM. I'm not sure what that is.
COM is.
So what he's referring to there?
It's Microsoft thing. Because it goes Java here. It's a Microsoft thing. It's old Microsoft.
Oh yeah, that's right. That's right. Okay, but also in a lot of languages, observers are implemented as classes in the language. So in Java, you have the observer interface and the observable class. So yeah, let's take the observer pattern and apply it to this case study, the e-commerce app. So first, we can look at the problem for clues to what is varying, and then try to encapsulate the verification. I'm sorry, the variation. There are different kinds of objects. There's a list of objects that need to be notified by a change in state, and they tend to belong to different classes. And because they belong to different classes, they tend to have different interfaces. So they can't all be called the same way. So we need a common interface. So step one is to make the observers behave in the same way. We want all of the observers to have the same interface. And if they don't have the same interface, it would be very hard to modify the subject, in this case, the customer, because it would need to be able to trigger multiple classes with different interfaces instead of just using the same one. So by having all of the observers be the same type, basically have the same interface, then it's very easy to notify them all. So in C# or Java, you would do this with an interface. In in C++, you might use single inheritance or multiple inheritance. In Ruby, we would probably use either like a single inheritance or do something like a module and include this. That's right. Just using an include or extend. Step two is that we have observers register themselves. So instead of the observable, or in this case, the customer, knowing about all of the different classes that will be taking actions based on events. It's the observer's responsibility to tell the observable object that they exist and need to be notified. So yeah, that's what he says here. And to do this, he is creating two different methods, attach and detach. So attach, it adds the given observer to a list of observers, and detach removes the given observer from the list of observers. So this will be on the customer class. Okay, and step 3 is to notify the observers when an event occurs. And all this comes down to is just a simple loop. If you already have a list of observers or an array of observers, you just iterate over them and call a common method defined in the interface, in this case, notify. And that way it's very easy for the observable class to just notify everyone that's subscribed, all of the observers that have subscribed that the events occurred. And step 4 is to get information from the subject. So once these observers are called, they're notified and told an event has taken place. It's not uncommon for them to have to go ask the original object for some sort of state information. That's what's being shown here in this diagram as the entire interaction. This is usually accomplished through properties or just some methods on the observable object. You can imagine if customer was a model, you would just have standard getter type methods to get the values of the attributes. And then those observer classes would be able to just go talk to the customer that notified them to find out more information. And that's pretty much the gist of the pattern. Put down. This is kind of just explaining what we just looked at here. In this diagram, the observers attach themselves to the customer by calling the attach and detach methods from the customer. Then when a new customer is added, the notify method from the customer calls the observer's update method, which, since they're all extending this common observer class, they'll all have that update method. Or sorry, interface. And so then they'll handle the update all in their own way. And then each observer can call the getState method to get whatever information they need to complete their action. So for welcome letter, you might, call the customer and get their email address, so you know where to send the email, that kind of thing. Okay, and the observer pattern aids flexibility and keeps things decoupled because it allows you to add new observers without affecting the existing classes. So we can demonstrate that easily with this e-commerce example by talking about a new requirement to send coupons. So in this case, we only need to send a letter with coupons to customers that are located within 20 miles of one of the company's brick and mortar stores. It obviously doesn't make sense to send coupons to someone that doesn't live within range of the store. So in this case, we see the full code implementation here. You can see we have the main loop for the notifying observers, which just iterates over each of the observers that were added via the attach and detach, the attach method, or remove via the remove method. Then you have the two original classes, the observers, the address verification, and welcome letter. And let's see what he's going to do next. I thought he had this in the code. Maybe this code example is just from the beginning. he doesn't have the third one in here yet. Sorry. But yeah, so what he's going to do, if you just look at this code, you can imagine you just add another class that also implements the myObserver. And in his diagram here, you see it's just the brick and mortar class, which also is an observer that would attach itself to the customer. So the pattern in the real world, sometimes a class will become an observer. Sorry, a class that already exists will become an observer. So if you don't want to modify your original class, but you still want it to be an observer, you could do so with the adapter pattern. And I think we've seen that before. It's just that we're going to add this. We want our class welcome letter or address verification to also be observers. So we use the adapter pattern to do that, so that we're calling the adapter class. The adapter class is the observer instead of the welcome letter address verification having to be modified to become observers. And as you said before, this is a special note to Java developers, is that there is an observer pattern that's implemented in Java. So if you use Java, you already have this. Their methods are not named the same though. Instead of being attach, detach, and notify like the author suggests, they use add observer, delete observer, and notify observers. Probably just because there's already so much going on in Java, they don't want to assume that you're not going to already have attach, detach, and notify implemented. Okay, field notes. He notes that the observer pattern is not meant to be used every time there's a dependency between objects. We can easily see that would be kind of a waste. If you know what the requirements are, if they're fixed, then it would just be too complex to add the observer to every interaction between objects. Instead, you just call the class you want to call directly, kind of like the original example. It's more useful when you have multiple objects, a list of objects that need to be notified and do something when an event happens, or if they're somehow conditional. That way you can decouple that conditional logic from the, like for example here, the customer class. You would instead put it in the brick and mortar class where it belongs. And the only thing the brick and mortar class needs to know about, the customer needs to know about the brick and mortar is that it exists and update can be called on it to have it do whatever it needs to do. So bringing this down to the key features of the pattern, there's the intent is to define a one-to-many dependency between objects so that when one object changes state, all of the dependents are notified and updated automatically. And this is, again, really common in software, especially in big distributed systems. In fact, we use message queues to accomplish this between applications. When this is common in that case. For example, you could put a message into a queue and then multiple applications receive it. This is the same thing, but just between classes only. So it's still useful. So the problem is that you need to notify varying lists of objects and events that occurred, and we solve it by delegating the responsibility for monitoring for an event to a central object, the subject. The participants and collaborators, there's the subject, and that's like the customer in the example. And it knows about observers because the observer registered with it using the attach method. The subject notifies the observers when the event in question occurs. Then the observers are responsible for both registering with the subject and for then getting the information from the subject when they're notified. Consequences. Subjects may tell observers about the events they do not need to know. If some observers are only interested in a subset of events, So for example, the brick and mortar might get a notification that doesn't actually need to act on, because once it actually looks at the customer and sees that they live more than 20 miles away, it knows it doesn't need to send coupons. Or you might even have a more complicated scenario in which maybe you're handling multiple events, and let's say that there's like a customer create event and a customer delete event. Maybe only some observers need to react to the create, and some need to react to the delete, and they would see what the customer state is to know what to do. So obviously, half of them wouldn't need to do anything. So you can see how that might be a little bit of a waste. And if you knew the requirements exactly, you would just call it exactly the classes that needed to be called, and not waste any, processing. But yeah, that's just kind of a as a consequence if you only have one message type, like you do here. As we saw for the implementation, you have observer objects that want to know when an event happens. They attach themselves to another object, the subject, and the subject is just they're waiting for the event to occur and for the subject to notify them. When the event occurs, the subject tells the observers that it's occurred, and sometimes you use the adapter pattern if you can't make those observers follow the or use the interface directly. You can use an adapter to use the observer interface and then call the original class. I don't know how common that is, but could happen. And here again is a full diagram of the pattern, which I believe is directly from the Gang of Four book. Yeah. So some other subjects he kind of covers is, like we just talked about, whether to process an event. In the case of the brick and mortar, some notifications are filtered out. So you may have extraneous notifications. Maybe you didn't need to call the brick and mortar class at all, but because we're decoupling the logic from whether the brick and mortar needs to do its job or not from the customer wouldn't know which ones to call and which ones not to call. So this is, he has sort of a solution for that you could use the strategy pattern to test whether the notification should occur. So each observer could then give the subject a strategy to use for determining whether or not that observer should be called. So kind of complicated. I guess you would only do this if that brick and mortar testing was, I don't know, just like really expensive or complicated. I don't know of any reason why you would do that actually, because it's just complicating this even more. Maybe if you wanted to reuse that logic for determining whether the observer is notified for multiple observers. So maybe you have multiple actions you wanted to take that had the same conditioning around them. Maybe this would make sense. But then you could just use that logic in the observer as like a module or something you include in multiple observers. So again, I still don't know why you would have that logic in a subject. But okay, also how to process an event. Sometimes subjects will call observers update method, passing along information. This can save the need for callbacks from the observer to the subject. So what he's saying is you can implement because we have the update method here on the observers. He's saying instead of letting the observer call back to the concrete subject or to the subject that was the observable, to get the state information, you can just pass that information. But as he notes here, it's often the case that different observers have different information requirements. So if you wanted to still do this, you could use another strategy pattern to determine which information needed to be passed to each observer. Again, I think that's just getting really, really complicated. It's a lot simpler just to pass the instance of the subject through the update method and let the observer determine which information it needs from the subject. And I think in the context of like Ruby on Rails, that makes more sense, since usually it's going to be like a model. But yeah, I guess this is just some issues you might run into and possible solutions, but again, that might just be a little too complicated for most cases. But in summary, we look at the observer pattern and see what he's saying here. Yeah, so the gist of the observer pattern is that an object that's triggering an event can't anticipate every single object that might need to know about the event. So instead, you separate out the responsibilities into this pub-sub type of relationship between the subject and the observers. And we can also see from this pattern some of the object-oriented principles that are used in the pattern. So here's kind of a table here of concept and some discussion on each one. So objects are responsible for themselves. There are different kinds of observers, but all of them gathered the information they needed from the subject and took the action appropriate for them on their own. So yeah, that's pretty good feature of this pattern, I guess, is that you really are splitting out the responsibility a lot, which is why he wanted an entirely different category for them as a decoupling pattern instead of being just behavioral. Abstract classes. The observer class represents the concept of objects that need to be notified, and it gave a common interface for the subject to notify the observers. That's in the form of the attach, detach, and notify methods that are implemented in the observable or subject class, whatever you want to call it. Polymorphic encapsulation. The subject did not know what kind of observer it was communicating with. Essentially, the observer class encapsulated the particular observer's present. This means that if I get a new observers in the future, the subject does not need to change. So yeah, if you were using a language that required that you type everything, all of your variables, the subject obviously wouldn't know anything about the address verification or brick and mortar classes. It wouldn't even have their names. It would just be storing them as an array of or a list of observers, which would be the interface. So that's the polymorphic part. So okay, on to the review questions. According to the Gang of Four, what are structural patterns responsible for?
Pick me.
I can pick you. I was going to answer them, but I'll just pick Forrest for all of them.
Okay, there you go. Yeah, so structural are about bringing objects together, which some of his other questions kind of relate to that interpretation. But bringing existing objects together, allowing things to collaborate, that's what structure is. All right.
Yep, okay, so question 2 is, what are the 3 classifications of patterns according to the Gang of Four, and what's the 4th one that the author suggests? And I can answer them. So, and I'll go back to the original table just to review them. Creational, which is to create or instantiate objects. Structural, which is to bring together existing objects. Behavioral, which is to give a way to manifest flexible or varying behavior, which is the only one we talked about as a strategy pattern. And then the fourth one that the author created was the decoupling category.
Yeah, I kind of feel like all patterns try to decouple.
True.
I think all good O practices try to decouple. So it's like, oh, aren't all of them decoupling patterns? So.
Yeah, I think probably the original three categories are just fun, but this one is just specifically really good at decoupling, I guess.
Yeah.
It's really, really obvious that's what it's doing. Okay, so what's the one true thing about requirements? I'll make Andrew answer this one.
They always change.
Yes.
They're known up front and they never change.
We know this very well.
Done, look for a new job.
I write code for God, and so he's like, here are the 10 commandments. No, I'm just kidding. That was a bad joke. I should have thought about it more.
Yes, well, we do have a process manager by the same name.
Okay, so question 4, what's the intent of the observer pattern? And we can just go back to the original Gang of 4 intent to define a one-to-many dependency between objects so that when one object changes state, all the dependencies are notified and updated automatically. So it's to create that one-to-many relationship between objects. Hey, interpretation. Why are the bridge and decorator patterns more correctly classified as structural rather than behavioral patterns?
Because they bring together existing objects, even though you were, his sentence was for the bridge, even though we're looking at from the abstractions down, it's like, well, there's these objects over here and how you bring them together and join them. And decorator also is just adding features to existing things.
Okay, number 2, one example of the observer pattern from outside of software is a radio station. It broadcasts a signal, and anyone who's interested can tune in and listen to what they want to. What's another example from real life? And actually, I must have glossed over that. Wasn't in my highlighted sections, but he compared the observer pattern to a radio in a car radio. So he said that a radio station obviously just blasts out signal, right? And every car radio that wishes to subscribe would just pick up that signal and then do something with it, right? If you were doing it the hard-coded way instead of the observer way, it would be like you had to modify the radio station every time a new car came to town. That was his example. Because otherwise it wouldn't know how to communicate with that specific car. Obviously, that's not the way that radios physically work, but still was kind of his example if you didn't have a publish, subscribe type of thing. But what's another example from real life? Forrest.
Real life. Well, I was going to say real life, but I was going to give a lot of code examples at the end of this.
Yeah.
Pub sub. I think that if you change observer to pub sub, that kind of, at least for people that are familiar with that concept, that becomes a lot more revealing. I don't know. I can say Twitter. Yeah. Twitter is real life pub sub. The feed is there. You subscribe to people, and then you can have that. But to adjust that, you can have it pushed to your phone. Like, I can have everything that Don tweets pushed to my phone. So there's subtleties upon the observer that you can do that I'll talk about after all the questions are over, because I have some good examples. But this Twitter account, is that not real world? They want like physical listening. Is that what? I think that's kind of what he wants.
Yeah, I think he wants like physical
computer example.
Yeah.
It could be the play that's in the park. It's going on, and you can come in if you want and watch it, and you can leave if you don't want to.
Right.
I think another one could be like job listings. You go to your newspaper or like some internet source, there are like all these job listings, and like some of them might relate and some of them might not. And then another one I was thinking of, like those secret spy messages that they encode on like certain frequencies, and it's like, oh, this is gibberish to me, but to like an agent on the field, he's like, okay, great, I'll assassinate the prime minister today or something.
Yeah, and like Forrest, I think of software patterns with this. The fact that an alternate name for it is PubSub just makes me think about message queues, because we use them all the time.
Example. Yeah, message queue is it's a generic PubSub mechanism. So it is the pattern, and you do whatever you want with it.
Yep. And then, you know, of course, you don't have classes and interfaces and all of that. It's just messages. So yeah. Because that's so common, it's obvious this pattern is used a lot, although in a different way. Okay, so under what conditions should an observer pattern not be used?
I always figure like those are weird questions. Like, when do you not use a hammer? When you don't need to get things or pull things out.
And I think what he said was that if you know the requirements, or like if you just need to call one thing, and you're pretty sure it's not going to change, then observer pattern would be overkill to do that.
I would say that for a lot of patterns, if you don't need the additional complexity, don't use it. Which for some people is hard to know.
Yeah. So I guess specifically, I think if it's not one-to-many, or if you don't care that much about decoupling, because maybe the two classes that are communicating are very related, something like that. Okay, so then in the opinion and application section, there's just one question. The fourth category of patterns somewhat includes patterns from other categories. Is this a good idea? Why or why not?
I go, well, I don't know, but that seems to be more confusing to me. Back to the thing where I go, I thought they all kind of decouple. So, and first thing in my mind, the category is not necessary, but it's complex. Oh, what pattern? Well, this is actually in two categories. It's this and that. Like, oh, when is that useful?
Yeah, I agree. I don't think the fourth category is needed.
All right. So, anyone want any comments before I go off and talk a little bit about observers?
I have a comment, but I forgot it. I might remember it once you're done.
All right. So, observer is one of those patterns that I came up with before I ever studied design patterns. So it's one that I know really well. And then something I always say, if you ever came up with a pattern on your own, then you read it and go, oh yeah, I did that. It's the one that you really understand. And I believe the classes I called were like listeners, right? I'd look up and I'd add listeners, and then I can't remember what it was that I, maybe my code was updated. Maybe I probably use words like listener and notify. Right, and you can see the PubSub, and to some people, those words might make more sense, but that's really powerful. So when you talk about what ones you use together, so monitoring, because we're talking about writing new monitors, that's completely observer. You have these flows of information. You have guys that want to listen, and they'll do different things. Part of the whole decoupling thing is just because I want this event, what I do with is different than what that guy does with it. And the beauty is the observable guy doesn't need to know. You just add to them, you register yourself, it adds to it, and then it just sends you stuff. So I've used this pattern, I don't know, tons and tons of time. And something that you use this in is like, forget, games, controls, distributed programs with controls. So I often combine command pattern with this, because I have people that listen on different machines and they do different things and they have commands, and arguably I'm pub subbing, but I'm doing commands. I'm using the command pattern with the observer pattern. And the other thing he was talking about, what do you say? So he was talking about how do you filter? Well, some pub subs is you can say what messages you want to listen to. So you put a different thing like you can add yourself, but when you add yourself, say, I add me and send me these messages. Like maybe there's 10 kinds of events, but I only care about 2. He was talking about writing the strategy pattern. Well, you could build it so your interface to add specifies which categories you take. And that's probably pretty close to how most generic pub sub systems work. Subscribe to this channel or subscribe to this channel and these events, and then you don't have to put a strategy there. And then vice versa on the other side, you said, well, how do you know which ones you notify? Well, that's completely SRP. You can get extraneous messages and just ignore them. You can subscribe to everything and then decide internally, hey, I only want to do blah, blah, blah. You know, if message is type A, then do something else, nothing. I don't see it being that hard. And how you set that up, if you're controlling it all, you can evolve to something that unfortunately will involve you to change the interfaces, because you can make this totally generic thing. Here, I'll just pass everything to everybody all the time. That's usually a good way to go, because what happens sometimes is you pass something and it's not enough, and you have to add it, and there's different, I don't know if they cover here, but there's patterns, and there's certainly a refactoring pattern where you keep adding more and more stuff to what you pass, and you decide, oh, just send the parent object. So then the default sometimes is just send the parent object, and Don was talking about this, and then you can easily, you send the parent object and make all the accessors there, and you don't have to send any more objects, and then whatever. So that being said, something I use the observer pattern is talk to the cards, which people who aren't part of us guys, it's a real-time card wall that it hooks into Pivotal, pulls those cards, but displays it. So I'm gonna actually, I guess I'll share my thing and talk a little bit about, because I actually use PubSub on 2 levels. I'm looking real quick on my thing and picking something that doesn't say anything very revealing. Ultimately, I don't think it's very revealing. Application window. So we got a card wall here, right? And so what this works is everyone on the team, if I click vanity URL here, it clicks for everyone else who has it viewing. So we have the pub sub kind of in general, where our pub sub is among, because we have a distributed team, we're pub subbing at 2 levels. One level is we're all subscribing to this. I press this thing. Ultimately, across the wire, it said, you know, vanity URLs were pressed. And then over on your machine, you get the message, which I'm actually, in fact, using, I am using the, what's it called? It's the Vertex. I'm using actually Vertex pub sub channels. So I'm using a generic pub sub to make this multi-thing, but even within this app, I'm pub sub. So then I have a handler on that pub sub channel, and that becomes its own. Like if you look at here, this top bar with the people button, that's an object. Each button is an object. And then the card wall itself here, that's an object, and the columns are objects, and the cards in the column are objects. So at the level of, hey, like I click on my name here, and of course this goes over the wire, pub sub 1, and then on this side, so on Andrew's machine, he gets this. So there's a listener, and again, I use that word because that's something, there's a listener on that channel that goes, and this, the object here, the button object and the card wall object are also listeners to the channel. And when they got a user change thing, they know, oh, Forrest has been selected. So then I deselect Don, and I select Forrest here. And this one, I know, I tell, hey, all the cards that belong to Forrest show up, all the cards that belong to Don go away. Then each card themselves go, hey, I'm visible, I'm not visible. So this, for more patterns. So you can imagine I have composite pattern in both of these where the button bar is made up of children. I get the notification, I turn around and tell all my children, hey, child, if you're not Forrest, uncheck yourself. If you are Forrest, check yourself. And over here, hey, card wall, Forrest has been checked. Okay, everyone. And I probably tell Don has been unchecked, or maybe I don't. But and then over, In this one, I tell the card wall tells the kids, or however I have it set up. But I know it's like I'm using a composite pattern, I'm using 2 levels of observers, I'm using command pattern because I'm getting, like I set up this, I named it pattern. I have a name for this way of using a pub sub channel to push commands where I have a command and data kind of pattern. So I push the right sort of things over the wire so I know things like, hey, this guy's up or whatever. I don't know if I do all that in this pattern, but I'm probably doing like 4 or 5 patterns in this one app with 2 levels of observer at least. But yeah, a lot of times you can channel observers. Observers go to something and something else is another thing that gets observed. And you can see, I get one event, click on this, and these 2 things act differently, but they both get the event that Jeff was clicked. Right, and so you can do a lot within an app, which is where he's talking about. Which you can see for, in our case, everyone who uses this tool, we're remote things. So real-time stuff, games make a lot of use of observer. You can imagine you have a real-time clicker that basically sends out events and then various things listen, and even call the observer, you can see it's just stuff that tells other stuff that has lists of stuff and stuff happens. And again, if you SRP everything, so everything is decoupled. I could add a third something that if it responds to Jeff was clicked and it does something entirely, like a timer. Like we were talking about adding a timer to this. So if I add a timer when the Jeff's clicked, I reset the timer. Maybe we want down the road, we want to track how long on average Jeff talks or whatever it is, right? That's all stuff. It's like, works really good. So I've done this tons and tons of times. I came up with it long before the design patterns book was written. So it's like, it's a pattern I understand. Because I solved problems that required this as an answer, I really understand this pattern well. There's like 3 or 4 patterns I go, I know super well because I came up with them before I ever read design patterns. So yeah, so there you go. There's my real life example. Back to like question 3. What's a real life example? Here's a real life example. So I'm gonna unshare that now. And okay, so any other questions, comments?
So I just remember what I wanted to say. It's not necessary to change what the subject is sending if you have a new observer, although you would think that if you have a new type of observer, you would add types of messages that it should respond to. But it's not necessary. You just have like a dangling observer that doesn't do anything because it doesn't respond to any of the messages ever. And then on the flip side, I was thinking in a real life pattern could be your cable box where you get all these channels. But if your subscription, your cable box says, oh no, you're not allowed to watch stars because you don't have this bundle. And also a new type of observer could be like, oh, now I have a video on demand box that does, that records television for me. So now it subscribes to the original cable source, but then none of the other observers, none of the cable box, other types of cable boxes do. So that's kind of like what I was thinking, like where it might be where a subject can turn on functionality on an observer, just depending on the message, whether the observer is able to get it or not. So I thought that's an interesting way to think about it.
All right, anything else? Anyone other have personal? I think always the best part, if you have personal experience with these, that's what enriches the study group. Where I can show you stuff or talk insights, and like I said, in my case, I've done lots and lots of stuff, observers on observers, and then other patterns, I think the cooler thing is when you come up with these, you evolve towards this. You try some stuff and it didn't work, and you try to figure, well, how do I decouple it? Oh, I have a new kind of like the things they said I've lived through. Hey, I have this new requirement. I have this new widget and it needs to be updated now. Well, how do I genericize this interface? Oh, and so it's interesting to watch the code evolve into something that's generic. So I have this like the first-hand experience. Oh yeah, just pass the parent object. Send in like an event type and then pass the parent object, and then the interface never changes. You still may have to change code in the parent to change what's available or the individual client, but it's relatively limited to, in that case, at least only 2 places. And I've definitely evolved I've evolved to like certain practices that I've seen from the changes that I've made. But yeah, like observer, it's a real common pattern. I mean, we have pub/sub networks all the time, so it's a handy generic thing that people realize it's just generally useful for distributed communication. You can do that within the app. You can do it across apps. Yeah. Anything. Okay. Well, then I guess we'll wrap it here. Next week, we got the template method. If I recall, did Andrew say he was going to do that one?
Yep.
I'm like 1, 2, 3, 4, 5, 6, 7, 8, 11 pages. Everything. Oh, we'll stick with one, right? It's shortish, but template methods, that's another great pattern. That's a pattern I have a lot of experience with also. And once you grok it, it's really powerful. I think a lot of these, it's not clear. Like hopefully my Talk to the Cards app showed you in a more complex and also something that you come across a lot. Like that's a thing that you use Observer all over the place. And once you get a feeling, oh, this is what I use this for, it becomes useful. Template method is a very powerful, very practical pattern, I think. And after that is factories. Okay, we'll leave it at that. And if it's short, it's short, instead of trying to put 2 in. All right. Thank you for listening to Nested Loops. Enjoy your day.
See you.
Mm-hmm.